In this video I'm going to show you how to approach solving the Jetstream problem. So the first thing you want to do is start taking notes. Flying against a jet stream, a jet travels 3,300 miles in 6 hours. So I'm noticing here that they're saying against the jet stream, and this is the information when they're going against the jet stream. So they're traveling 3,300 miles, this is a distance, and 6 hours, which is a time. Flying with the jet stream, so now we're saying with the jet stream, the same jet travels 2,610 miles. Again, this is a distance, and this is in 3 hours. That's a time. What is the rate of the jet in still air? So we want to find the rate of the jet in still air and the rate of the jet stream. So we want two different things. Notice that it doesn't say that they're related. It doesn't say that one is faster or slower than the other. Therefore, we're going to have two different variables in this problem. I'm going to call this one X, and I'm going to call this one Y. And what I'm going to do now is just kind of go over the jet stream, what they mean. Think of jet stream as like the force of the wind, what's happening. So let's say that the jet stream is going this direction. That's the jet stream. Well, if I'm going in the same direction as a jet stream, that is with the jet stream. And if I'm going the opposite direction, that's against. So when they say in the first sentence flying against a jet stream, then I'm going to use that in this information here where it says against. So I'm going to put that now. It says that they traveled 3,300 miles, so that was my distance. So my distance was 3,300 miles, and then the time was 6 hours when you were going against the jet stream, so 6 hours. And then if you're going with the jet stream, so I'm going to organize it under this information. With the jet stream, it traveled a distance of 2,610 miles, and then it took it 3 hours to travel with it. And if you think about it, it makes sense, because if you're going with the jet stream, that means that you're getting a boost. That means you're going to finish it much faster. And then I'm also going to write down my unknown. So X, the unknown, we said is going to be the rate of the jet, and this is going to be in still air. And when they say still air, that just means if you don't consider the wind factor. So if there was no wind, there's no jet stream, it's just still air, then they want to know how fast is it actually going. And then we also need the rate of the jet stream. So how much force is that wind pushing? Is that jet stream going? Against and with. So what is the rate of that jet stream? Next, we have to figure out how to relate the information we were given. So notice we were given a distance and a time for each one. So notice over here they're saying to find the rate. They want you to find the rate, which means we have to find a formula that relates the rate, the distance, and the time, which I know is the distance formula, which is distance equals rate times time. And I'm going to use two different formulas, and I'm going to set it up the same way. So I'm going to keep it organized the same way, where I'm going to use the formula with the jet stream, and I'm going to use the formula again when I'm going against the jet stream. So I'm just organizing it so I can see better what's happening. So let's substitute into my formulas. I know my distance is 2,610 when I'm going with the wind. The rate, I don't know, but I mentioned earlier, if you're going with the wind, you're getting a boost. So think about it. If you're getting a boost, are we adding or subtracting in this case the rate of the jet and the rate of the jet stream? In this case, you're going to be adding. So the rate of the jet plus the rate of the jet stream will tell me how fast I'm going. In other words, if let's say you're going 1,000 miles per hour, and then the wind is pushing you an extra 100 miles per hour, then guess what? Then I'm going 1,100 miles per hour. So basically you're combining those two things to get your actual rate. So that's what we're doing. We're adding X and Y together. And then we multiply that with the time it took, which was 3 hours. And now I repeat the same thing against the wind. Against the wind, my distance was 3,300. The rate was unknown, but we do know that you're going against the wind. So ask yourself, are you going to go faster or slower? So if I'm going against, I know I'm going slower, right? It took me more time to go against the jet stream. I'm going slower, therefore in this case I'm going to subtract the rate of the jet minus the rate of the jet stream, because I know that whatever rate the jet is going at, the jet stream is going to slow it down by a certain amount, so I have to subtract in this case. And then I multiply that with the time it took, which was 6 hours. And next I'm just going to simplify my two equations. So I have 2610 equals, and I could distribute here if I want to, and I get 3x plus 3y. And then in the other one I get 3300 equals, and doing the same thing, I get 6x minus 6y. And if you notice, now I have a system of equations, and now I can actually go ahead and solve this using the elimination method because they're both written in standard form. So I'm just going to put 2610 equals 3x plus 3y. The other one is 3300 equals 6x minus 6y. And now I'm just going to use the elimination method to go about solving this. And I can clearly see here that my y's are opposite signs already. And all I have to do is multiply the top one by 2 so I can make them the opposite numbers as well. And I'll do that to both sides. Now I'm going to rewrite both equations. 2 times 2610 is 5,220 equals, and I distribute my 2 here. I get 6x plus 6y. And my equation underneath stays the same. And notice my y's are opposites now, which is the goal in elimination method. Let me just scroll down a little bit here. And now I'm going to add the two equations. We're going to get 12x on the right side. My y's cancel. And then if I add these two equations, I'm going to get 8520. All I have to do next is to divide both sides by 12. And I get x equals 710. And I just found x. And don't forget, earlier I labeled x as the rate of the jet in the still air. So now we know the rate of the jet was going 710 miles per hour. And now all I have to do is find the rate of the jet stream. So to do that, I'm going to pick one of my equations. It doesn't matter because they're going to have the same solution. But you just pick the one you think is going to be easier to solve for the other missing variable, which is the y we're going to solve for. And I'm just going to pick this one with 2610. So 2610 equals 3 parentheses x we found out to be 710. And now I only have to find what y equals. So I'm just going to keep simplifying and solving out for y. So 3 times 710 is 2130 plus 3y. Now I subtract 2130 to both sides. And then I get 3y, scroll down a little bit, equals 480. Then divide both sides by 3. And I get y equals 160. So now I have my two unknown variables solved for. I know the rate, and that's why it's important to label your x and your y. You can see that x is the rate of the jet in still air, and y is the rate of the jet stream. And this is how you solve the jet stream problem.